each other, okay? First, we're going to talk about vibration, and actually, we mainly concerned about vibration, shaft alignment, and balancing. And I believe that most of us get in contact with vibration, whether direct measuring vibration, or at least get in contact with the vibrating equipment, or exposed to vibration reports. He responsible to apply or reading, or responsible to comply with the requirement of this report somehow. That's why actually vibration is very important to be understood with the engineers, technicians, anyone who is responsible or in contact with the machine, directly in contact with the machine. That's why we just quick briefing about vibration in this session, handling some of or mostly those topics, but of course not deeply, but we just try to cover most of the useful knowledge about these topics. Okay. So I believe that most of you get in contact with vibration somehow, plus or minus. So if you get in contact with vibration, whether you are directly measuring vibration, or maintenance, or this kind of contact, would you please press 1 in chat? And 2, if you have no idea about vibration at all. Then if you have some sort of experience, just press 1. And if you don't have any experience about vibration, it's your first time to hear about it, just press 2. Okay. One or two? Okay, 1. That's fine. Okay. When we talk about this curve, I believe that most of us know what this curve means. Actually, this is what we called the bathtub curve. What this bathtub curve representing, or what this curve tells us exactly? Actually, this curve is representing the equipment life cycle, starting from beginning to the end. Okay. Then from this area, or this first part of this curve, this is what we called infant mortality. The infant mortality part of the curve. And this actually representing the beginning of equipment life. In this beginning, we can see that probability of failure of the probability of having interruption in operation, in installation, in failure rate increase in this area. This is actually the beginning of the equipment life. Why we have this high rate? Why? Because simply we have a lot of unknown things at this beginning. Like if you have new equipment, new installed equipment, of course we have a lot of things starting from maybe you get wrong installation, wrong selection, still need some adjustment for normal operation. All of this increasing the probability of failure. That's why we found the curve in this area is a little bit has high probability of failure. But after time, after you finish all of these problems, you found that the failure rate start to be normal or very low actually. And in this area, in this period, we call random failure. Okay, this is what we call random failure area. Here, what I mean of random failure. In random failure area, actually, we don't know exactly when the failure happened. Maybe here, maybe here, maybe here, maybe here. But the most useful thing that the failure could happen here. If we succeed to run equipment to this point, this will be a very good position. Why? Because simply you used the equipment lifetime to the end of its life, which means you are utilized all the spend money to take all the benefit from this spare part or this equipment until it start to fail. The last part of this bathtub curve, what we call wear out period. And in this wear out period, actually, the equipment start to fail not due to any interruption or any abnormality, but it start to fail due to lifetime. Okay? Until now, everything is fine, everything is clear? Okay. If everything is fine, just press 1 in chat, just to make sure that you can understand and hear me. Okay, perfect. Then actually, it's very, very important for us to succeed, to use or utilize all the equipment life until it reach its end of the life. But actually, this is not the actual case. Then, what the actual case? The actual case that not all the equipment fail due to its lifetime, but they are divided in both age-related failure and random failure. The equipment failed due to age-related failure, it's like 11%, only 11%. But most of the equipment, which is almost about 90%, failed randomly. What do I mean randomly? Randomly that I don't know exactly when it started to fail or when it failed already. Because when we talk about failure doesn't mean it just fail like this, but it takes time. It takes steps to get failed. Let me show you something. Okay. Here, let me open the camera. You can see me now? Okay, nice. This account. Okay. Okay. Look to this bearing. What this? Can you see this part? Here. Can you see? If you see this one clear, just press 1. Okay. Okay, nice. So what the reason make this one? What this? It's an inner race, bearing inner race, right? It's bearing inner race. And what you think the reason makes this happen here? This one. What do you think? If you can open your mic, open the mic and tell me. Do you know what the reason make this kind of failure? Okay, as you can see from here, you can see it's like a pattern of failure. Like this one is a dent. Here it's another dent. Here it's another dent, and so on. This actually not coming from a regular failure, but it's coming from what? It's coming from a very unique failure called false Brenling. What does false Brenling mean? False Brenling actually, when you have motor like this, and this motor, let's say, is connected to fan, and for some reason you stop this one, you stop the motor. But of course, as you know that the cooler is not coming alone, but it's working in bays or in bundles, and this bundle had many coolers. Then normally we have many coolers at the same bundles, maybe 2, 4, it depends. Let's say we have 4 coolers here, 3 in service and 1 stopped. In this case, the vibration will start to transmit from the operating cooler to the stopped cooler. And due to this transmitted vibration, the bearing here, whether it's drive end or non-drive end, start to vibrate internally. The vibration start to transmit to this bearing until start to make this kind of dents. And this is what we called actually false brilling. Like this. Like this, as you can see here. Even you can see that the distance between these dents is equal. How long it takes to make this failure? What do you think? How long it takes to make this failure? Think, starting like if you install this one today, how long it takes to make this failure? Write in chat, how long are you expecting to have this failure after installation? 1 month, 1 week, 1 year? Okay. Random. Yes, exactly. It's random. We don't know. And it also depends. Maybe the equipment running, maybe the equipment stopped. Maybe there is high transmitted vibration. Maybe they don't have this kind of transmitted vibration. That's why, according to standard, there is some special standard for foundation to avoid this kind of transmission. That's why this kind of failure makes the random failure very high. Then 90% is a very reasonable percentage because we don't have the capability to predict all the failures could happen to the equipment. But only around 10% of the equipment is just follow the equipment lifetime and fail according to this lifetime. That makes us very curious about having early detection about failure, because 90% of the equipment failed randomly. We don't know exactly when it starts to fail. And according to this, maintenance has been classified to some groups. Like maintenance is divided to unplanned and planned maintenance. When we say planned maintenance, this planned maintenance could be corrective and could be preventive. And you may ask me, what you mean by corrective? Corrective means the equipment is failed. Okay, let me tell you. Equipment failed, what that means? Does it mean it's breakdown? Or it means that the equipment gives you an early detection about failure? Like in this case, in this bearing, the bearing is not failed. But we catch the bearing in early stage here. In early stage, it's not damaged. It just failed or not failed. It's not performing as we been expecting, or at least it started giving us a high vibration, which is not accepting as their standard. Like here. This bearing is still unfailed bearing. It's still one piece. But this one has been replaced due to high vibration. Then we can still doing corrective maintenance, but this corrective maintenance action coming from condition monitoring. But when we talk about unplanned maintenance, it means breakdown maintenance, which coming due to failure, sudden failure, unplanned failure. But when we talk about corrective maintenance, it's coming from condition monitoring, which could be planned as bare condition, machine condition. Then you detect vibration, and you've been expecting the vibration or the equipment have 2 months to fail, still has 2 months to fail. then I can plan within these 2 months replacement of this bearing or make this kind of maintenance or whatever maintenance required for this equipment could be planned as per measurement and analysis. Okay? Okay. Preventive maintenance also could be classified to fixed and predictive. Oh, you told me before that this corrective maintenance is coming from condition-based maintenance. Then what this mean? It's predictive maintenance here. How it's coming here and here? Okay, let me tell you something, that this predictive maintenance is not the result of measurement, but it's the activity itself. Like when I'm saying I'm measuring vibration every month, once per month, or once per week, what this? Is it preventive maintenance or this predictive maintenance or it's corrective maintenance in this case? I mean the measurement itself. Here, the measurement itself is what? Is preventive. Measuring vibration, periodic measuring vibration is preventive. Oil sampling, periodic oil sampling is preventive. Infrathermography, ultrasound, NDT, any kind of condition monitoring periodically based, which means that you do this activity based on time or running hours. This considered as a preventive maintenance, timely based, whether timely based, running hour based, or whatever, but it's still under time based. Fixed mean like overalls. After this number of running hours, I have to do this kind of maintenance. I need to do this overalls and so on like this. That's why we classify the preventive maintenance in both fixed and predictive. But as I told you, predictive here is related to condition monitoring. And according to this predictive maintenance, okay, you get a result or reporting according to the machine condition. Then you do what? Condition-based maintenance. Then condition-based maintenance depends on condition monitoring. Okay? And for fixed maintenance, fixed preventive maintenance is classified to daily maintenance basis, like housekeeping, monitoring something, measuring something. This kind is fixed, whether you're running or not, but you have to monitor, you have to keeping. And time-based maintenance, like overalls, like maintenance based on the running hours, and so on. That's how we classify maintenance to unplanned and planned. But actually, we classify them to before and after failure. Here, this after failure. Then the equipment is already failed, and you do the what we call firefighting maintenance or unplanned maintenance. It's already failed. But here before failure. Then the most important is we keep doing our maintenance in this area before failure. Don't wait for after failure. Okay. Is everything clear? If everything is clear and you can hear me and you understand, just press 1. Okay. Kindly press 1 in chat. Okay, okay, nice. Let's continue. Then, according to this, we need to have better understanding about vibration. Then, if I have vibrating object like this, and this one, just when I pull it down like this, and leave, it start to vibrating. This is what we call free vibration. Free vibration, which means the vibration, this object is vibrating freely. You just apply one force and leave it vibrate. But the most important question in this case, what the frequency of vibration here? Okay, here the object start to vibrate under what we called the natural frequency. The natural frequency. Exactly, Mr. Ali. The natural frequency. Okay? Okay. We have another type of vibration we call forced vibration. Forced vibration. In this forced vibration is not like free vibration, just pull and leave, but you just holding this object and keep moving this object under the force of your hand. Then this object start to vibrate with what? With which frequency? With the same frequency of your hand. With the same frequency of your hand. Here we can ask a very important question. What the mean of frequency itself? What the mean of frequency? Frequency is repeated action per second. Like I take a second as a unit time and I count how many times this action repeated per second. Then if I have, for example, this motor and this motor running under or with 1500 RPM, then how many revolution done per second? Please write in chat. How many revolution per second is 25? Exactly, Mr. Akram. It's 25 per second, 25 revolution per second. Then the frequency of this motor is 25 hertz. The hertz is the measurement unit, the frequency measurement unit. And according to this, we start to define every object frequency. Like this impeller, this pump, this belt, this fan, bearing, unbalance, bearing, and so on. Which means the frequency case is like a fingerprint for each defect or each problem. Then we have now free vibration and we have forced vibration. Free vibration, when you just excite object and leave it freely vibrate, but forced vibration, when you vibrate any object or machine under certain force. And in this case, the object or the machine or this part start to vibrate with the same frequency of the exciting force. And when we talk about exciting force here, that means the defect force, the defect, like as I told you, like bearing, unbalance, misalignment, or whatever. This what we call the exciting force. Then representing vibration could be done in a very simple way by representing this as a simple harmonic motion. Like here, if you pull this mass spring system and leave it freely vibrate, this will start to create what we call sine waveform. Okay, then the vibration itself could be represented as a sine waveform. Why? To just simplifying the equations, the motion. How you describe this kind of motion, this movement? Because how many motion we have in nature, in physics? How many motions? We have linear motion, we have rotational motion, and we have vibration motion. Okay? Then we have these three types of motion: linear, rotation, and vibration. Then it's very important to simplify the motion in a way you can describing or put a governance equation to govern this kind of motion. And the most important thing after you describing this vibrating motion is to quantifying this motion. How much of this motion? Because it's vibrating up and down, up and down, up and down. I don't know exactly how I describe the amount of this motion. Then, in this case, we need to describe the time waveform, because here we're representing this movement, because this oscillation motion by time giving this what we call time waveform, which is the relation between amplitude and time. This time waveform could be represented in three forms. It's actually four forms, but normally we use only three forms: peak value, and peak to peak value, and RMS value. Mathematically, there is an average value, but we don't use it in vibration. Normally, we use these three values only: peak to peak, peak, and RMS value. Okay? What I mean peak? Peak, the distance between center line and the maximum or minimum, or minimum. Peak to peak, the distance between top and bottom. Top and bottom. But the RMS value, which is the root mean square value, equal 0.707A. What is A? It's amplitude, it's peak value here. Then RMS value is 0.707, the peak value. And we're going to see later deeply in our course that how we can utilize all these three values to analyze exactly the defects. Because each criteria, each defect has its own criteria, its own behavior. If you exactly need to represent the actual machine, you can represent each part of this machine as spring mass system and connect them all together, giving us the multi-degree of freedom, because each mass spring system alone has its own degree of freedom. Like here, this one is moving vertically, another one moved horizontal, another one move in Z direction. Then mostly we have three directions, X, Y, Z. This is the freedom direction. But actually we have 6 degrees of freedom, X, Y, Z, and rotation X, rotation Y, rotation Z. That's why we have 6 degrees of freedom in normal. If you connect all these parts together, it starts to behave differently than each separate part alone. Then, when I'm talking about bump, I'm not talking about only bump as a as one unit, but this bump is made from different parts: two bearings, shaft, mechanical seal, splash ring, throwers, impeller, whatever. All these components together make bump. Any change for each part, any change for any part of this will change its behavior. That's why sometimes when you have a very normal vibration bump or equipment and go for overhaul, after this overhaul, you found the vibration is high or the behavior of this equipment start to change and you don't know exactly what happened. Honestly, you don't have the same equipment before overhaul, but after overhaul, it's completely different equipment now. Then you need to start from beginning. And in this case, after overhaul, actually, you will start the best curve from beginning again. Here. This one. After overhaul, you will start from zero. You will have this high probability of failure in the infant mortality, and then start working monitoring until you get the random failure period, low rate of failure. And after that, when the equipment complete its running to overhaul, running hours to overhaul, you start the third stage, which is the wear out. Okay. By monitoring each part of this complex vibration or all this machine together, all these components together, it starts producing what we call the complex vibration or complex time waveform. Could be represented like here, as you can see the complex, very complex time waveform, okay? And in this very complex time waveform, is not easy to detect defects. Like if I have imbalance, if I have misalignment, every component or every problem of this have certain criteria, have certain pattern actually. But as long as you have a very complex vibration, it's not easy to distinguish between defects and can be analyzed easily. That's why we need to transfer this, instead of having the amplitude and the time relationship making this time waveform, we need to transfer to spectrum, which is actually the relation between amplitude and frequency instead of time. Then vibration is a result of two things: the input force and the response give us vibration. Then you can eliminate or reduce the vibration by controlling any one of them or both of them. And actually, some reasons or some source of vibration coming from the input forces and some other sources coming from the response like resonance, like anything related to natural frequency, like resonance, okay? And the input forces like unbalance, misalignment, any other defects also leading to vibration. Then transferring the time form to spectrum is a very mandatory, very important to transfer through what we call FFT or fast Fourier transform. By this way, we can simplifying the analysis and simplifying the vibration visualization. Instead of have this complex time waveform, start to having a very simple spectrum, which is the relation between amplitude and frequency instead of amplitude and time. As you can see, this is a relation, or this what we call the spectrum. This time waveform. Here, the relation between amplitude and time. But here, the relation between amplitude and frequency. You can see here the frequency in hertz here. Direction of measurements, of course, is very important, especially when you have some specific defects like misalignment, unbalance. You can even detect these kind of failures mainly by direction and, of course, by analysis. But direction is very useful tool in analysis also. And normally we take 3 directions: horizontal, vertical, and axial, to visualize how this object or this machine is vibrating. Because I told you before, we have 3 degrees of freedom. That's why when you measure 3 directions, you visualizing exactly how this machine is vibrating. And according to this, you can detect or analyze the defect. Okay. Then if everything is okay, just press 1. Tap 1 in chat. Okay, nice. Okay. Also in vibration course, in this course, we'll talk about resonance. And actually, resonance is very destructive phenomenon. And this happens when we have matching, between the exciting force and the natural force, natural frequency. Sorry. And in this case, we find the resonance case. And this resonance is very destructive, and we need to avoid this one. Whether when we have the resonance in the stagnant or static equipment or in the rotating equipment. As you can see in this animation, you can see the effect that in case of resonance, the vibration is increased dramatically, and the control is only with damping. So it's very hard to control the vibration in this case, and the vibration amplitude will increase dramatically. That's why we need to avoid this phenomenon. A lot of defects could be detected using vibration, like misalignment, unbalance. All of these defects you can see on the screen right now could be detected actually by vibration, including the electrical defects, like if you have broken rotor bar, you have loosened coils, you have any problems related to electrical, like line unbalanced, or all of this also. Gears problem, bearing, of course, hydraulic flow turbulence, belt problem, beating. All of these effects could be detecting using vibration analysis. But you need to, let's say, utilize all the tools available, starting from signal processing to techniques using different units to manipulating and toggling between different parameters in order to figure out exactly what are the defects, and making sure. Even sometimes we need to take more than one measurement in different way just to verify the problem. And of course, to judge about the condition, we need to follow specific standards. Like here, we have this standard, 10816, and there is another one for relative vibration, which is 79 and 19. Okay. In this case, we have different criteria or different guidance to guide us whether this vibration level is accepted or rejected. Depends on the power, the foundation, the rigidity of the foundation, and the equipment power. A lot of case studies also we will manage in our course, including unbalance, misalignment, as I told you. If we talk about, for example, here about unbalance, what the meaning of unbalance? Balance, that means the mass distribution is not equal. That makes centrifugal forces exist. And as long as we have force, then we have forces making vibration. Okay? And also depend on the equipment response. Because vibration is a result between force and response. Three common types of unbalance exist, like static unbalance, dynamic, and coupled unbalance. Dynamic is the general case, which is like including both static and coupled. But we consider only coupled and dynamic in case we have wide rotor. But if we have narrow rotor, you can count it on static unbalance only. And normally, if I need to balance this rotor, what I have to do, I have to put another mass here, giving the same effect, the same force like this, but in the opposite direction, right? But it's not that easy because you don't know exactly where the unbalanced mass. Here you can see clearly because it's drawn, you can see in this graph, but in actual case, it's not like this. In actual case, if I have rotor, normally the density here different than here, than here, than here, and each part of this give force, give centrifugal force. And what we're dealing is actually we're dealing about the equivalent forces. Then it's very important when you go for balancing, you need to decide exactly what the amount of mass you need to add and when and where. As I told you, many measurements could be taken just to make sure that you have unbalance or any other of defects, because normally, as all we know, that unbalance show like 1x and sine wave form, but it's not only the case. I'm going to tell you that all the defects generating 1x, all the defects literally generating 1x. Then you need to take extra measurement, whether it's phase measurement or any directional measurement or any kind of measurement, other measurements also could be taken just to make sure about unbalance. And according to this, you take the proper action for correction. Okay. Is it clear? Okay. If it's clear, please press 1. Yes, the session will be recorded, and I'm going to share the link with you. As I told you, unbalance is showing up like 1x. What do I mean 1x? It means the running speed, the frequency of running speed. Also, mostly or almost pure sine wave form in time wave form, also good indication of unbalance. And the last part of our course will be shaft alignment. Then our course actually is divided in 3 parts. First one is vibration analysis, starting from signal processing, measurement, diagnosis, and the different techniques you are using for diagnose different defects, machine defects. Second part is balancing, how you balance, how you decide, or how you measure the balancing, how you calculate the corrective mass, what the standard we have to follow in order to judge about the acceptance or rejection of this residual imbalance. Okay, how you read the balancing report. And the last part in the course is shaft alignment. In shaft alignment, of course, we know about shaft alignment. Shaft alignment is very important. What I mean, it's like you need to make these two shafts between driver and driven, they are collinear together. Okay, but we have many factors affecting this collinearity. Like we have what we call thermal growth, soft foot, a lot of things actually, starting from pre-alignment check, and after that, the methods we follow, starting from the simple to complex one, from the cheap to more expensive one, like starting from rough alignment to laser alignment techniques. From this to this, a lot of steps and different accuracy, but you need to take care, like every one of these could get better result if you follow the accurate steps. Okay, that's why it's very important before you even start to make alignment, you need to make a pre-check alignment steps. Because if you start alignment without pre-check alignment, you may keep doing alignment without any good results unless you fix the problem making this. Like if you have a problem in foundation, you have a problem in leveling, you have thermal growth not calculated in a proper way. If you have bulbous rain, a lot of things could be leading to bad misalignment. Okay, and we have two main types of misalignment: parallel misalignment and angular misalignment, and of course combined misalignment. That's why when we start doing alignment, we need to fix one by one. Okay, we have vertical and horizontal. Vertical and the horizontal. Of course, we're starting with vertical so we can add or remove shims, and later we fix the horizontal direction. In both vertical and horizontal, we consider the parallel and angular misalignment. Okay. Okay. So right now we can open a little for questions if you have any questions. Do you have any questions? Okay. Anyway, if you don't have any question, that's fine. This session will be recorded, and you are in the group right now. So anything you can direct message me and me or the team. If you have any clarification, the team will reply to you. If you have any technical issue, I will reply to you. Never mind, just ask. Okay. If you don't have any question, just press 1. If you have question, you can write your question or even open your mic, speak. Don't worry.
Mr. Mu'taz, I have a question.
Yes, please.
Regarding the certificate vibration analysis category 1 and 2,
okay,
delivered by Mobius Institute.
Okay.
So you are doing this kind of training course to prepare?
Yes, actually, I have 13, which is like the next Monday. I have Cat 1, starting Cat 1.
Cat 1, okay.
Mm-hmm.
How long time to complete this training course for each category?
How long?
How it takes as a period to complete each session?
It's 4 days. I mean, it's 4 days right now.
But 4 days, it's enough to complete.
Cat 1. 5 days for Cat 2.
And for Cat 2? And Cat 3?
5 days. Cat 3 also 5 days. But you know that the material is increased when you increase the cat.
Yeah. But the question is, it's enough her to to collect all the information for, especially for the Cat2 and 3. The 5 days, it's enough. I think it's not enough now.
Normally, well, look, what I'm doing, we do the sessions, Cat 1, Cat 2, 3, whatever, and we record it. And you will have access to this record. Then if you don't even get it on time, you have enough time to repeat and remind everything. Okay?
Okay.
And supporting you until you get certified. We have
So-
here, I believe we have Mr. Hassan, Bashwans Hassan. He just gets certified the last week. باشمهندس حسن سامعنا؟
السلام عليكم.
عليكم السلام باشمهندس حسن، كيفك؟
ازيك يا دكتور؟ سامعك ان شاء الله.
حبيبنا هندسة.
Okay.
We can congratulate Engineer Hassan. He just certified Cat 2. He just finished his exam.
Okay, perfect. MashaAllah عليه.
Congratulations.
Thank you.
ما شاء الله.
My congratulations regarding this. Just the simulator, it's included, I think, to prepare to this exam.
Actually, yeah, you will have access to TMS for Mobius, and they have material for this.
Yes.
So it's mandatory. So to prepare from this, especially from the simulator. So I think it's very interesting.
Simulator, yes, is already included in. I mean, for I teaching from my side as an instructor, I will teach through the simulator. But for you as attendee, you will have another access to different material. Okay, but as I told you, you will have this one as a recorded. Then you can get back to this whenever you need it until you get certified.
Okay, perfect. Thank you, Mr. Matas. شكرا.
باشمهندس حسين نورتنا. حبيبي يا هندسه.
الله يخليك. شكرا.
الله يكرمك يا رب. Okay. Anyway, I would like to thank you all. If you have any question, I will be more than happy. Anyone need any question? Okay. Thank you all, and I wish to see you. And if you have anything you need to ask about, just don't hesitate. Just ask me directly. Ask me. Okay. Thank you all, and see you soon, inshallah. Thank you. Thank you.